Hello everyone. Let us now discuss how can we solve this problem. Power of 4. So we are given with an integer n, return true if it is a power of 4, otherwise return false. An integer n is a power of 4 if there exists an integer x such that n is equal to 4 power x. So here we are given with n is equal to 16. So 4 square is equal to 16. So we will return true. Now n is equal to 5. Can we represent 5 as 4 power something? No. So we return false there itself. But for example 3, 1 can be represented as 4 power 0. So we have returned true. Now the constants are minus 2 power 31 to 2 power 31 minus 1. So the follow-up is could you solve it without loops or recursion? But let us start with a recursion code first. So first thing, let us take an example like n is equal to 64. Now, is 64 divided by 4? What it will give? 4 ones are 4, 4 sixteens, 16 fours are 64, right? So now the remainder is 0, right? Now I got 16. 64 by 4, I got 16. Now when I do again, when I divide it again by 4, I got 0 as a reminder. And next 16 by 4 is nothing but 4 fours are 16. Now if I divide this again with 4, I get a remainder of 0. But now I got 1. Now when I get this 1, I'll stop there itself. But when n is equal to 5, 5 by 4 will give us something like 1, right? Four ones are 1, but the remainder is not 0, it is instead 1. So we'll return false there itself. So let us write the code for this. Here we are given with bool is power 4, something like this, int n. Now if n is equal to 1, then I had returned true there itself, right? Now if not, there are two cases. If and mod 4 is not equal to 0, then I will return false there itself. If not, or if n is equal to 0, then we will return false there itself. Now what I am returning every time, here if you see 64 by 4, I went and made 16 as n, and then 16 by 4 is 4, made n is equal to 4. So what I'll do is, wait a second, what I'll do is just return n by 4 as n. So return is power 4 of n by 4. So how does it work? So first thing is power 4, it will start with is power 4 starting with 64. Is n is equal to 1? No. Is n mod 4 is not equal to 0? No, it is not true. And is n is equal to 0? No, it is not true. So these two doesn't execute, and I will call for is power of n by 4. This will call for is power 4 of n by 4. N by 4 is 16. Now it is not 1, it is not 16 by 4 is equal to 0, but this is not true. N is not equal to 0, so this will not execute. And this will call for is power 4 of 16 by 4 is 4 fours are 16. So this has called for this. Now 4, now 4 will is it equal to 1? No. And n mod 4, 4 mod 4 is equal to 0. So this is not satisfied, and n is equal to 0. No, it's not satisfied. Then is power 4 n by 4 is power 4. 4 by 4 is nothing but 1. Now is it equal to 1? Yes. Then I'll return true. True. And this will return true here, true here, and then true here, and then true here. So this is how the recursion works. And there might be also a loop possibility, loop solution, but we should not waste our time by going through that loop. But let us understand how this 1 and 4, 4 fours are 16, 16 fours are 64, are these, how are these represented in bits? So 1 is represented as 1, all are zeros, right? Now 4 is represented as 1, 2, 4 here. Now again 16 is represented as 4 twos are right here and 16 here. Here 1 and remaining are 0. Now for 64, 1 all are 0. Now if you see at the position of 0, at the position of 2, at the position of 4, at the position of 6 and at the position of 8 and so on, only at even positions only at even positions I got set bit. But how many set bits I got? Only one set bit. So there are some conditions, right? First condition n should be greater than 0. Then only we can say it as power of 4. So 4 power of 4 can't be negative, right? No, cannot be negative. So n should be greater than 0 and only one set bit. And also this is the first condition and this is the second condition, and that set bit should be at even position, should be at even position. Now how can I know the third condition, that set bit should be at even position? So for that I'll use a bit representation of 0x triple five 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 five. So this is nothing but this represents a 32-bit representation where even positions even positions are set bits, right? Even positions are set bit. So what I'll do is I'll just return if n is greater than 0 and bit count. Wait a second. So, to know the total number of set bits in a number, I'll use built-in built-in pop count of n should be equal to 1. So, this is the first condition and this is the second condition, and the third condition is n ampersand 0x triple five double five. So this is how, if these three conditions satisfy, then I would return true. If not, I'll return false. So this is how you solve this problem. And if you have any doubts, so we have just solved it without using any loop or any recursion. So this is how you solve this. And if you have any doubts, please do comment in the comment section. And please do like, share, and subscribe to my channel. Thank you.